Okay, we are going to do, what am I doing? 3, 5, ready, set, go. I'm going to skip this part, the solving for x. Keep in mind on these ones with x squareds, remember there's probably two answers that will make this true. You can check my work if you need to. Any questions you have, just email or comment and I can make videos for them, but I think you're going to be fine there. I'm going to do all the division problems. I'm going to do that as one video. And then um, I don't know if I'm going to need to do videos of these or not. I think seeing the answers will be enough. I will tell you that on question 17, the domain and range is hard. I don't, I'm not too worried about this. This is a sequence. I think once you see it, you'll be like, oh, I see what's going on here. But I don't want you to hurt yourself on that. Pay special attention to question 18. On 18, the bracket on the domain and range, because there is an endpoint there. Pay attention to that. And the second thing, this guy here, 20 is really good. If you don't understand 20, I do want you to ask, especially this last piece. 20, I might do 20 actually before I leave. And then 21, same thing here with the domain and range. The domain and range is always hard on discrete data sets, and I'm not trying to trick you. So I don't want you to get too worried about that. But division is the most important thing on this. And on these problems, I'm going to do them the quickest way I can. So if synthetic division is an option, I would do synthetic division. If you did not watch the video on synthetic division, I encourage you to do so. So on question 1, I look and I'm wondering if I can do synthetic division, and the answer is yes. Yes, I can. I can do synthetic division because I'm dividing by a linear binomial with leading coefficient of 1. So I will put the opposite of the constant in the box, the -1. Okay, I'll write the coefficients here. 1, -3, 6, and 11. I will skip a line, draw a line, and drop the 1. After you set it up, you'll have your party. You will multiply and add. You will multiply and add. You will multiply and you will add. That is your remainder, your number, your x, and your x squared. This is not a factor. So your answer is going to be x squared minus 4x plus 10. If you take that times the x plus 1, you will have to add that remainder in order to get the x cubed minus 3x squared plus 6x plus 11. Or you could have wrote it like this, x squared minus 4x plus 10 plus 1 over x plus 1 times x plus 1. And you could have got that way as well. Okay, number 11, I can also do synthetically. This is a candidate. You'll put a positive 5 in the box. Coefficients, 1, -9, 23, and -15. Skip a line, draw a line. Oop, little downhills there, that's all right. And have a party. You multiply, you add. You multiply, you add. You multiply, and you add. This time there is no remainder, which means it is a factor, and x squared minus 4x plus 3 times x minus 5 will equal x cubed minus 9x squared plus 23x minus 15. You could go further if you want. This would factor to x minus 3, x minus 1. They didn't ask you to do that, but you should notice that while you're working these problems. Okay. Go to question 12, and I look, I'm like, ooh, dogs, I gotta do long division on this one. Okay, so this time I'm gonna do long division, which is fine, just a little disappointing since the other ones went so quickly. There are 2 pieces, so I'm gonna start 2 in here. And I need to see how many times the 2x goes into 2x cubed. So 2x cubed divided by 2x, that will be x squared. You will multiply, distribute down. That's 2x to the third minus x squared. Subtract all the pieces or change all the signs. That's 16x squared, drop down the minus 34x. And then you'll ask yourself, how many times does 2x go into 16x squared? So 16x squared over 2x, that'll be 8x times, positive 8x times, multiply down, 16x squared minus 8x change all the signs, and you will get a negative 26x. Drop down your plus 13. How many times does 2x go into negative 26x? Be negative 13 times. Multiply down, you get negative 26x plus 13. Change the signs, and you get no remainder. So it is a factor, and you get 2x minus 1 times x squared plus 8x minus 13. And that will equal the 2x cubed. I just don't think there's enough space for this. 15x squared minus 34x plus 13. Okay, 13 should make you happy because you can do synthetic. You'll put the opposite of the constant in the box and the coefficient. So I have x cubed, x squared, x, and a number. Skip a line, draw a line, and have a party. You multiply, you add, you multiply, you add, you multiply, and you add. We do get a remainder here, so it is not a factor. And you get x squared plus 9x minus 10 times x plus 4 plus 15 will equal the x cubed plus 13x squared. Or x squared plus 9x minus 10 plus 15 over x plus 4 times x plus 4 equals that guy. Okay, 2 more. We can do synthetic on 14, but not on 15. So for 14, you put a negative 7 in the box, x cubed, x squared, x, and a number. I didn't have to put a 0 in it on any of these. Skip a line, draw a line. Sometimes you do, so be careful with that. You multiply, you add. You multiply, I'm checking my work on this one. You add, you multiply, you add. Big remainder this time, 52. So I get x plus 7 times x squared minus 15x minus 6 plus 52 over x plus 7, or x plus 7, x squared minus 15x minus 6, close the parentheses, plus 52. Regardless, it would equal the x cubed. Okay. And the last one, we will do long division. X cubed, x squared, x a number. Everything is there. 2 pieces, so start 2 in. How many times does 3x go into 3x to the third? It's x squared. Multiply down. 3x cubed minus 4x squared. Change a sign, change a sign. 27x squared, drop the 6x. 3x go into 27x squared. It's 9x times 27x squared minus 36x. Change a sign, change a sign. That's a 42x. Drop down your minus 28. 42x divided by 3x. It's 14 times. That's 42x, and this is 56 minus 56. Be bad to make a sign mistakes there. Change a sign, and my remainder is 28. So it's not a factor. And the last answer is 3x minus 4 times x squared plus 9x plus 14. Add the 28, or 3x minus 4 x squared plus 9x plus 28 over 3x minus 4. That's so sloppy. And that would be, oh my God, equal to 3x, like my pen's checking. I'm sorry. This is ridiculous. Plus 6x minus 28. All right. Those are the division problems. And I said I wanted to do one more with you. Where to go? I want to talk to you about this guy. Number 20. Okay, the domain is what x is allowed to be, your left to right. It goes left to go forever, right forever. So your domain is negative infinity to positive infinity or all real numbers, up to you. The range is the down and up. It does go up forever, but it does bottom out right here at -5. And it can be -5. So the -5 is going to get a square bracket and it will go up forever. Increasing and decreasing, it's doing both. I like to go piece by piece so I don't mess anything up like I read it. So first the graph is decreasing. It's decreasing from negative infinity. And if I was going to cut where it is decreasing to, it's decreasing to -2. Then it starts to increase. And we use parentheses everywhere here because at those turning points, we're going to say it's neither increasing or decreasing. So it's -2 and then to 0 because then it starts to decrease again. So we're going to put a U here for union because now it's going to pick up decreasing again. It decreases from 0 to 3. And then it starts to increase again, 3 to infinity. Okay, the increasing, decreasing is a little tricky. The y-intercept is right here at 0, 4. And then the x-intercepts. There's an x-intercept here at -2, 0. There is one here at 2, 0. And there's actually one more. This guy will touch that x-intercept, x-axis again, I'm sorry. So you could either write an equation for the line, or you really can kind of count it out here. The slope is 1/2. Right here, I'm at 9. I'm at 11. It'd be at 13 right here. So my last x-intercept would be at 13, 0. I guess most of you would miss that last one. So be careful with that. If you have questions on the others, that I'm happy to do it. I don't want you to hurt yourself on these domain and range. Okay? The domain and range I don't want you to get upset about on 21, and I don't want you to get upset about the domain and range on this one here. The discrete sets are just hard. And I think once you see them, you're like, oh yeah, that makes sense. And that's really good enough for this.